It's a little late, but we have question number 14 from 5.2 review. And this is where we have a multiple battery system. We got two different voltage sources. So that means that I can't just reduce my circuit. I have to do some circuit analysis with this involving Kirchhoff's loops and the Kirchhoff's loop laws and his junction law. So I have a circuit drawn and it says that there is going to be a current flowing out of that junction, which means it's going to be flowing in over here, and I'm going to call that current I3. And I'm going to say, okay, I see that I've got a positive side, so I'm going to have current flowing this direction, and I'm going to call that I1. And I've got current flowing this way, and I'm going to call that I2. I should do all of those in different colors. So give me 1 second. This is I2. And we'll use this one. And we'll say that is I1. So I1, current coming up here, going through that wire. That's my I1. Going through the bottom, or through the middle, is I2. And the red one going around the bottom is I3. And according to the junction law, so junction law, at a junction, the sum of all currents equals 0. So I have current flowing in, that's I1 is flowing in. I have I2 flowing in, so I've got two inputs, so I1 plus I2. And then I3 is going out, so minus I3 equals 0. So all three of those together gives me a total of 0. So the sum at that junction, I've got no current because all the current coming in has to go out. All right, and that is my first equation. My second equation, now it depends on Kirchhoff's loops. And I'm going to draw a couple loops. And so if I'm going to start, I'll just pick a point here, and I'm going to make a loop of that top. And then I'm going to pick a point here and make a loop of that bottom. And so this is loop 1. And then this is loop 2. You could also make a loop going all the way around the outside and cutting out I2 if you want to. That's something, a third loop that you can do. But I only need to draw 2 more loops, so because I have 3 variables, I need 3 equations. So I'm just going to do this top loop and this bottom loop. All right, so as I go this direction, I'm going from negative to positive, and when I do that, that's a voltage rise. So I'm going from the small side to the big side. So I have a plus 1.6 volts. And that's my first device. I go on through and I'm going, let me draw my current. The current we've said is going this direction. And my loop, I'm going in the same direction as my current. So that is a voltage drop. My resistor is dropping off some voltage. It's using some of that potential difference. So it's a minus. And it's, I would say it's a minus V, but I don't know the voltage of it. I just know the current and the resistance, so 12 I1. And then I go down here, and I'm going around my loop. The next device I run into is this resistor in the middle, and I would be going the opposite direction. So I'm looking around my loop going from left to right, but current is flowing right to left, so opposite directions, that's a voltage gain. So plus 32 I2. And now I get to, as I go around to get to my other battery, and I'm going from positive to negative, so that's a voltage drop, minus 1.6 equals 0, because once I get through there, there's nothing, no more devices till I get back to the beginning. And so that is equation number 1. That is my top loop. All right, my bottom loop, I'm going to use a different color. I don't have any more colors quickly. Let me pull out maybe a light yellow. and I'll make a light yellow loop. So I'm going to start here and go around that direction, and I go from negative to positive, so that's a voltage rise, plus 1.6 volts. Then I'm going the same direction as the current through my resistor, so that's a voltage drop, minus 32I2. Then I go around here and I run into another resistor. Let me get my red, and we said the current is going that way, and I am going, how I drew my loop, I'm going in the same direction as the current, so it's a voltage drop, so minus 33I3, and then I don't have any more devices and I go back up there, equals 0. Okay, so that's my bottom loop. And now I have set up everything I need. I've got 3 equations, 3 unknowns. I'm gonna rewrite them all so that all of my I1s are in one column, then all of my I2s, and all of my I3s, and then all of my values. What does that equal? My things without my variables are gonna go on the other side. So my top loop, I've got a positive 1.5 and a negative, 1.6 and a negative 1.6. So those are gonna cancel out, and this is going to equal 0. I have an I1, I see that I1 there, so minus 12 I1. I have an I2, and I said I2 is going to be green, so plus 32 I2. And I don't have any I3s in that top loop, so minus or plus 0 I3. All right, and that's my equation number 2. Equation number 3. I've got a positive 1.6. I don't see any other whole numbers, so I'm going to move that to the other side, and so it's going to equal negative 1.6. And now I1, I don't see any I1s, so 0 I1 plus an I2, I have a negative 32, so plus negative 32 I2. I should have just made that minus. Let me erase this. Minus 32. And then we have 1 I3 minus 33 I3. Okay, so I've set up all of my equations. Now I'm going to bring in my calculator and go to apps and polysmelt 32, so app number 9, and we want to do the simultaneous equation solver, so that's number 2, and I have 3 unknowns, so 3 equations, 3 unknowns. We want it to be everything else is okay, so next. Alright, so I have a 1 I1 plus 1 I2 minus 1 I3 equals 0. So minus 12. Invalid input. So I have to hit minus 12 plus 32. I2 plus 0 equals 0. Alright, now I have 0 I1 minus 32 I2 minus 33 equals negative 1.6. And now I will solve. And I'm going to flip that to decimal form. And I have found all of my currents. My I1 is 0.027, my I2 is 0.010, my I3 is 0.0383, and I could find everything out once I know those. I could find the voltage across each device, I could find the power dissipated through each device. But for this problem, it wanted to know, is this current drawn in the proper direction? And how would I know that? Well, my Z, I3, is positive, so that means that this is a valid drawing. So I would be able to say yes, because my current is positive when I set it up with these junctions and all of my loops acting this way. If it was a negative value, then I know it would be backwards. All right, so that is number 14. I hope that was helpful. If you have more questions, let me know.